right, so we've got a polynomial, we're given one of its zeros, and we are tasked with finding the rest of the real zeros. There was another video with this same problem, and we used long division for that. But if we wanted to do this in a little bit quicker way, we can use synthetic division. So let's go ahead and do that. We know that if we have this statement here, c equal 3 is a 0 of multiplicity 2. Again, this means the same thing as it did in the last one. So x minus 3 squared is a factor of our polynomial. And again, with the same thing happens here. Our goal is to write our polynomial as a product of this and some other polynomial. Okay, so last time we did this using long division. We just took our original polynomial and we divided it by x minus 3 squared. So the first thing we did there was we squared this, and then we did that long division process. But this, as we've probably seen in the textbook, is a bit easier if we do synthetic division. Now, synthetic division looks like it is, they talk about synthetic division on page, let me just write this in synthetic division. Page 259 through well, looks like it just starts on 259, and it kind of goes for a bit with that example. Maybe 263 is when that stops. But anyway, we can do synthetic division here. It's just another way of doing polynomial long division. So we want to take our 0, and we'll put that up in the corner here. And then we're going to take all the coefficients of the polynomial that we are dividing into. So 2, negative 11, 11, 15, and negative 9. Okay, so we want to do our nice synthetic division. So we've got this down steps-wise, and if we don't, it's detailed pretty well there in the text. So we've got all of our coefficients of the original polynomial here. We've got our 0, or we've got our given 0 there. So we can do the steps. So the first thing we do, we bring that 2 down. And now we multiply. So 3 times 2 is 6, so we put it here. And then we add. Negative 11 plus 6 would be negative 5. Multiply 3 times negative 5, we got negative 15. And then we add. So that would give us negative 4. And then we got 3 times negative 4 would be negative 12. We add, we get 3. And then we do 3 times 3 is 9. And we add, and we get 0. And this is what we expected. This is expected because c equal 3 is a 0. That means that there's going to be a 0 remainder when we divide. And this is from the factor theorem, or I guess the remainder theorem, maybe the combination of the two. Okay, so now this is not what we wanted. We only divided by x minus 3 once. We want to divide by it twice because it's a 0 of multiplicity 2. So we can just take our coefficients here and just kind of construct ourselves another synthetic division bar guy, whatever they call that. And we can just repeat the process, right? So we'll bring down our 2. We multiply 3 times 2 is 6. Add these together, we get 1. 3 times 1 is 3. Add these together, we get negative 1. 3 times negative 1 is negative 3. And now we add these together, we get 0. And again, here we got a 0 remainder. Which again, we expected that because, well, it's a 0 of multiplicity 2. Now, if we went and did that a third time, that's not going to end up with a 0 remainder. Maybe you can give that a shot, but we probably don't need to do that here. Okay, so what we just did was we found that other polynomial. So we can say that we can write the polynomial is x minus 3 squared times some other polynomial. And these are the coefficients, right? So here's your constant term, linear term, quadratic term. So we can write 2x squared plus x minus 1. And now we can finish this out just like we did that last time. So really the only thing different that we did here is we used synthetic division instead of polynomial long division. Now, if you're more comfortable with polynomial long division, you go for it. And it takes a little bit longer, but it absolutely is going to get you to the same result, provided we don't make some little error, like maybe the ones I pointed out in the other video. Okay, so anyway, we need to figure this, or finish this out rather. So we can just factor this. We know that the first term in both of these is going to be an x. We know that the coefficients on these x's have to multiply to be 2. Well, there aren't any real choices there. It's just a 2 and a 1. And now we have that our second terms in both of these have to multiply to be -1. Well, there aren't really any choices. There aren't too many choices there either, right? We've got -1 and +1, and that's it. So we want to end up with a +1, so we want this to be larger. So we'll make that be positive and that be negative. And we can check this too, right? If we multiplied these together, we'd have 2x squared. There it is. We've got 2x minus x would be x. There it is. And we got -1 times 1. So there it is. Okay, so then this tells us when we're trying to find the zeros of our polynomial, what we're doing is we're solving p of x equals 0. So if we're setting this equals 0, we have that zero product property that says if I've got a string of factors that their product is 0, one of them has to be 0. Well, what this tells us is that x minus 3 squared is 0, or 2x minus 1 equals 0, or x plus 1 equals 0. Okay, so we can solve these all pretty quickly, right? If we take and do that square root of both sides, we would have x minus 3 equals 0. So this really only amounts to x equals 3. This one here, we'd add 1, divide by 2, x is 1/2. And then on this guy, we would have just subtract the 1, so x is -1. So we have x equal 3, x equal -1, or excuse me, positive 1/2, and then x equal -1. Well, we already had this one, so we would insert these two in the box if we're asked to find the remaining zeros, because we already knew that x equal 3 was a 0. Anyway, we did that with synthetic division.